Hello everyone, in this video I want to demo a macro I authored recently for a user who wanted for OptiStruct to define thermal load, so convection, which is a load to be applied on solid element faces, and he wanted to do a kind of equation along that, which means the value of the convection was not the same between lower Z and upper Z. And this is something which is not available yet in HyperMesh core. So let me show you how I authored the macro. Let me run the macro first. So for the moment, there is no sets, no load in the environment. Let me click on File, Load, Script. Let me go into my folder to run the script. And you will see that the script creates on the fly the different sets. So there will be something like 10 sets. So it will be pretty fast, and not only it creates sets but also the loads. So let's just have a look, and now you see that I have the facets with different colors, one for each of my range of set axes, and I have a load too for the different loads. And you here, for instance, I modify the head transfer coefficient, and you see that every time the value is different. So what does the macro look like? There are few values to be initialized at the top. So here my cylinder is along Z, so I define the X and Y center. I define my number of steps, so it can be changed. I define my element size, and I'm defining the inner node radius. So the inner node radius, just to give you an idea, I'm just taking this point, and generally I do some kind of rounding, or at least I make sure that my distance is between 180 here and 182 in order not to pick the second row of nodes, which is why I pick 181. Then I'm doing some math just to define let's say the Z steps, how many range, the range of the height of any of my Z step. Once I've done this, so set and load, I can loop over the set and load creation, and the majority of the lines up to line 51, they are for the set, and especially because we need the faces to be identified. Though in a few words, I'm selecting the first range of elements, I'm selecting the first range of nodes, and from this, for each element, when it comes to defining facets and not picking only all the elements, I need in the set to define its set element, but its facet. And to define these facets, I need to select not only the elements, but also the facet ID to be kept. So for doing this, I need to check which facet has its 4 nodes belonging to the inner selection of the nodes. So this is what is happening in this loop here, where I'm looping over the 6 faces of my element. For each face, I'm collecting the 4 nodes of the face, and if the 4 nodes on the face lay along the internal faces of the cylinder, then I have these checks, and I return the face index, which is the one that I want to express. And then I can create the set or populate the set with the proper lists of element IDs and facet IDs. Then I just have to create the loads with the set that I created previously and different type of values. So here I had a fixed value, and then I have my mathematical formula. So here I said that I wanted the convection to be twice the square value of the Z average plus 3 multiplied by the Z average. And by the way, the Z average is for one interval, it's the mid value of the interval. So here's one way to create such facet-based sets. Hope this can help. Thank you for reviewing this video.